Okay, in this video we're going to take a look at the symmetry of the unit circle. And just to remind ourselves here, we need to remember that the unit circle has a radius of 1 and a center at 0, 0. And theta is just defined as being anti-clockwise from the positive x-axis. We know that the sine of theta is equal to y, the cos of theta is equal to x, and the tan of theta is equal to sine theta over cos theta, or y over x. So the unit circle is divided into 4 different quadrants, and they're numbered as follows. So this quadrant here is where you've got both positive values of x and y is the first quadrant, and then to the left of that is the second quadrant, third quadrant, and fourth quadrant. Okay, so you'd need to have the numbering correct. When I refer to the first or the second quadrant, you need to know what we're talking about. So there's relationships between the circular functions, sine, cos, and tan, that we can establish based on their symmetrical properties. Okay, so taking a look at the first quadrant here, so this is where all values of x and y are going to be positive. So that means that the sine of theta, we know, is going to be equal to the value of y. The cos of theta is equal to x, and the tan of theta is equal to y over x. And because all of these values for x and y are positive, means the values for all of these are also positive. Okay, so what that means is if you put sine of theta, and theta is an angle that's in this first quadrant, so that means it would be between 0 and pi over 2 radians, or 0 and 90 degrees, an acute angle. That means that the value of sine of that angle, or cos of that angle, or tan of that angle will always be positive. Now let's take a look and see what happens if we put an angle in quadrant 2. So we'll say that this is also theta. So sorry, I know that doesn't look like the same angle, but it should be the same angle as that. Now we're talking about in quadrant 2, we're talking about obtuse angles. So we're talking about angles that are between pi over 2 and pi radians. So the angles that we're talking about, if we want to relate them to our first angle, theta, these angles here are all going to be pi minus theta, okay, or 180 degrees minus theta. And this point in the circle now, this point is going to now have a negative x coordinate and a positive y coordinate. Okay, or we can think about that as negative cos theta and positive sine theta. So let's take a look at how this affects the values of sine, cos, and tan. So the sine of an obtuse angle, so something that's pi minus theta, is going to be equal to the y coordinate, which is positive. So it's going to be the exact same value of sine of theta. But the cos of pi minus theta is equal to the negative x coordinate. So that means it's equal to the negative cos of theta. Okay, and tan of theta, or sorry, tan of pi minus theta, so tan of an obtuse angle, is going to now be y divided by negative x, which is also going to give us a negative value for tan. So in the second quadrant, when we're talking about angles that are obtuse, okay, between 90 and 180 degrees, only sine is positive. Everything else will give us a negative value. Okay, so if you took an obtuse angle like 135 degrees, if you put in your calculator sine of 135 degrees, you'll see that you get a positive number. But if you put in cos of 135 degrees, you see you get a negative number. Okay, now let's take a look at what happens in the third quadrant. So this is where we have angles that are between pi and 3 pi over 2, or an angle between 180 and 270 degrees. So if I draw in a corresponding angle here, so this would be the same as theta, my whole angle as measured from the positive x-axis would be pi plus theta. Okay, so angles in the third quadrant are going to be pi plus theta when theta is an acute angle. So the point in this circle here, P, that's going to be a negative x value and a negative y value, or P is going to be negative cos theta, negative sine theta. So that means when we have angles in the third quadrant, so if I take the sine of pi plus theta, that's going to be equal to the negative sine of theta. And if I take the cos of pi plus theta, that's equal to the negative of cos theta. But if I take the tan of pi plus theta, so the tan of an angle between 180 and 270 degrees, that's going to be equal to negative y over negative x, which is going to give me a positive value. So the tan of pi plus theta is equal just to the tan of theta. So in the third quadrant, only tan will give us positive values. So let's take a look at this fourth quadrant here. So this is where we're looking at angles that are between 3 pi over 2 and 2 pi. So if I drew in my angle here, so that would be theta, then that whole angle as measured from the positive x-axis would be a whole rotation 2 pi minus whatever theta is. Okay, so if I look at this point P here now, the x-coordinate is going to be positive in this quadrant, but the y-coordinate is going to be negative, or we would have a positive value for cosine and a negative value for sine. Okay, so that means that if I have an angle that is 2 pi minus theta, so between, this would be 270 and 360 degrees, that's going to give me a negative value for sine. So it's going to be equal to the negative of sine theta. For cosine, though, we've got a positive value. So the cos of 2 pi minus theta is just equal to the cos of theta. And for tan, you've probably worked out by now, the tan of 2 pi minus theta, because we've got negative y divided by x, that's going to give me a negative value for theta. So in the fourth quadrant, only cosine is positive. Okay, so there's a handy little sort of mnemonic to help us remember which circular functions are positive where, and we call that the cast rule. Now, the only annoying thing about this rule is that you have to actually start in the fourth quadrant. So the word cast, in the fourth quadrant, we can see cosine is positive, all of the ratios are positive, sine is positive, and then tan is positive. And this is something that I still use to help remind me which ones are positive and which ones are negative for each quadrant. Okay, so how are we going to use this? So if we take a look here, we've got the cos of theta is equal to 0.47. Now this is saying what's the value of cos of negative theta? So I'm just going to draw a little diagram here. Okay, now we're saying that cos of theta is equal to 0.47. Negative theta would be down here in this quadrant, so that would be negative theta. And from the cast rule, I know that values of cosine in that quadrant are positive, so that's just going to be equal to the same value, the same positive value. So if cos theta is 0.47, then the cos of negative theta is also 0.47. Now let's take a look at B over here. So I've got, now, here's my theta. The cos of pi minus theta is going to be in this quadrant here. Okay, so that's going to be in the second quadrant. So if I write in my cast, I know that only sine is positive in this quadrant. So that means that the value of cosine for this angle here is going to be negative 0.47. Okay, the third one here, we've got cos of pi plus theta. So there's my theta. Pi plus theta is going to end up in the third quadrant. So there's my cast rule. I know that in the third quadrant only tan is positive, so that means cosine has to be negative. And cos of 2 pi plus theta, well, 2 pi plus theta, there's 2 pi plus theta, just is exactly the same angle as the cos of theta. So that's going to be the same value, which is positive 0.47. Okay, so we'll just try two more practice questions. So here we have, if tan of theta is equal to 1.2, what is tan of 2 pi minus theta? Okay, so if we have our theta here, then 2 pi minus theta is going to be in this quadrant here. So that whole angle would be 2 pi minus theta. And using our CAST rule, C-A-S-T, we know that in this quadrant here, only cosine is positive, so tan will have to be negative. So therefore we can write that the tan of 2 pi minus theta is just going to be equal to the negative tan of whatever theta is. From the question, we know that tan of theta is 1.2, so this will be equal to negative 1.2. And the last question, if cos of x is equal to cos of pi over 3, and x is between 3 pi over 2 and 2 pi, then what is x? So let's just take a look at what we're given and what this question is actually asking. So we're told that cos of x is equal to cos of pi over 3. So the angle pi over 3 is an acute angle, so it's going to be in this first quadrant, so we'll say that that is pi over 3. Now we're told that x that we're looking for is between 3 pi over 2 and 2 pi. So you should recognize that that's between 3 pi over 2 is 270 degrees and 2 pi is 360 degrees. So then that angle is going to fall in this quadrant here. Okay, so this angle here, so this would be pi over 3. So that means that the angle that we're looking for is going to be 2 pi minus pi over 3. Okay, so that means that x would have to be whatever the angle 2 pi minus pi over 3 is, which is going to be equal to 2 pi. You can change to 6 pi over 3 to get a common denominator, which is 5 pi over 3. So x would have to be equal to 5 pi over 3. And that also makes sense because we know that from the CAST rule that cosine is positive in this quadrant and positive in this quadrant. So they're equal to each other. Okay guys, so now you can have a go at exercise 16E.